So just a little disclaimer right off the bat. This question is going to involve a bunch of algebra, so feel free to just fast forward through the video as fast as you want. It's mostly just going to be algebra, not so much the physics. So without further ado, part A says to find the speed of a proton that has the same kinetic energy as the electron. So we were given the speed of the electron. It's 0.750 times the speed of light. Now that is an incredibly fast velocity, or that's an incredibly fast speed, so we cannot neglect any relativistic effects on the particles here. So that means we have to use the relativistic kinetic energy, and that just makes the algebra way more complicated. So let's get to it. So here is our relativistic kinetic energy formula. Now in black represents the electron, so everything written in black is the variables that represent the electron, and in red represents the variables for the proton. So if you see a red M, that's going to be the mass of a proton. Now these I also have the speed of light written in black here. Well, the speed of light is constant in both terms. It's nothing different from both sides of the equation. What I'm going to do now is I'm going to go ahead and cancel out the speed of light on both sides of the equation, and then after I'm going to go ahead and plug in the values that we either know or were given from the question. So the mass of an electron is 9.11 times 10 to the minus 31 kilograms, and we were told that the speed of the electron is this number right here. Well, I went ahead and skipped a few steps, and if you've done many questions involving this formula, you'll know that the C's cancel out and you're just left with this right here. So all you have to do is square that number. And once again, I'm going to subtract the mass of the electron. And what I did here is I pulled out, or I factored out, the mass of the proton. And the mass of a proton is 1.67 times 10 to the minus 27 kilograms. Afterwards, I went ahead and reduced this into one numerical number, which was 4.663 times 10 to the negative 31st. And I went ahead and divided the mass of the proton right here. I also went ahead and added this 1 right here to this side of the equation so that I get this form right here. So then afterwards, this all reduces down into the numerical value of 1.0002792, and we set that equal to 1 over the square over this radical right here. So again, the physics has already ended. We're just dealing with algebra. Now we're trying to solve for V right here, and because it's written in red, we're trying to find the speed or the velocity of the proton. What I did here is I squared the values so that this now becomes 1.0005585, and I set that equal to 1 divided by 1 minus v squared over c squared. The next thing I did was I inverted everything, or you could cross multiply and divide, but I found it easier just to invert both of these right here. Afterwards, I moved the 1 over to the other side. Well, you just have to rearrange this equation so that you isolate the v squared divided by the c squared. Next, I took the square root on both sides and I cross multiplied, and that gives me a velocity of 0.0236 times the speed of light. On to part B. It says find the speed of a proton that has the same momentum as the electron. Once again, we have to use the relativistic momentum, and that is mv divided by the square root of 1 minus v over c squared. And again, in red, this represents the proton, and in black, this represents the variables for the electron. I went ahead and plugged in all the masses and the speeds, and then I condensed this form right here. So all these numbers right here become 3.09893 times 10 to the minus 22. And then what I quickly did is I divided the mass of the proton right here. So we have 1.67 times 10 to the minus 27th. And then what I did is I squared this entire expression right here so that we could get rid of the square root on this side of the equation. So this is what it gets simplified down to. So I went ahead and found the numerical value of this expression right here, and that gives us 3.443 times 10 to the 10th, which is equal to v squared divided by 1 minus v squared over c squared. Afterwards, what I did was I cross-multiplied and I rearranged some of the expressions so that it gets simplified down into this form right here. Afterwards, I multiplied the entire equation or each term by the speed of light squared so that we get rid of this denominator right here. Afterwards, I factored out the v squared expression or the v squared variable so that I get this right here. And in about like 2 or 3 steps that I added here, I divided this expression right here, or this term right here, and I took the square root so that I'm left with just the velocity. So we get that the velocity is equal to the square root of 3.443 times 10 to the 10th times the speed of light squared divided by 3.443 times 10 to the 10th power plus the speed of light squared. And when you punch that all out in your calculator, you get a velocity or the speed of the proton to be 185,565 meters per second. Hopefully that helps. If you found any mistake in my algebra here, please leave a comment so that I could revise this. And thanks for watching.